Example number 4. A man launches his boat from point A on a bank of straight river, 3 kilometers wide. So 3 kilometers is from A to C. And wants to reach point B, which is 8 kilometers downstream on the opposite bank. So this is mean 8 kilometers as quickly as possible. He could row his boat directly across the river to point C, then run to B, or he could row directly to B, or he could row to some point D between C and D, and then run to B. If he can row 6 kilometers per hour and run 8 kilometers per hour, where should he land to reach B as soon as possible? So you look at the picture and you can see that, of course, the point D somewhere between C and B will give him the fastest time to reach to B. He row and then run will be better, will be the best to save the time. Okay, so we have the distance from, let's call this distance is the x from C to D. Then the distance from D to B is A minus x. Then we have AD. Using Pythagorean theorem, we will have x squared plus 9. So we know the formula is the distance is rate times the time. So if we want to solve for the time, is equal to the distance divided by the rate. So we can apply this formula. So we have the time t in terms of x is equal to the square root of x squared plus 9 over 6 plus 8 minus x over 8. So this is the time that's for row, and this is the time that for run. Okay, so row is from A to D, so which is right here, and we have AD is x squared plus 9 square root, and divided by time they give us in the problem is 6. And then we have the run time is, which is right here, from B to D, A minus the x, and then divided by the time, which is 8 kilometers per hour. We notice that the x distance, the smallest value is 0, and the biggest value is 8. So now let's take the first derivative for the time. So we will use the chain rule here. So we're gonna have 1 over 6, and then times x over x squared plus 9, and then minus 1 over 8 equal to 0. So to find the interval where t prime increasing, decreasing, and the critical point, we will set the t prime equal to 0. That means 1 over 6 square root of x squared plus 9 minus 1 over 8 equal to 0. And that's equal to 1 over 8. We add 1 over 8 both sides. Okay, let's simplify this a little bit. So if I multiply this by 2 for both sides, then I got 1 over square root of x plus 9 1 over 4. and then we do cross multiply. So we will have, so we're missing the x right here, right? Okay, so we will have 4x equal 3 square root of x squared plus 9. Now let's square both sides to get rid of the root. So we get 16x squared equal 9, x squared plus 9. Then we open the parentheses and then solve for the x squared or x. So we get 7x squared equal 81, and then x squared equal 81 over 7. So x equal plus minus 9 over square root of 7. However, we have the x restriction before is greater than 0. So we only take x equal to 9 over square root of 7. So x cannot be negative number because it's distant. Okay, so we have the endpoint. So let's go ahead and plug in the endpoint. So we have t of 0, t of 9 over square root of 7, and we have t of 8. So for these three value here, and we can see that this is 1.5. So we have 1 plus square root of 7 over 8. So we will get the answer is about 1.33. And the last one, square root of 73 over 6. So 1.42. Okay, so if we do not do the interval, so if we do the interval from 0 and 8, and then we have 9 over square root of 7, so you can see that it's going to be like this and like this, right? Okay, so minus and plus. We did not do that. We plug in the points, and obviously we can see that the smallest value is 9 over square root of 7, give the time is 1.33. Okay, so we answer that we should now go back to the question to see what do they ask us to do. So they ask us where should he land to reach B so that we get the shortest time. So it's gonna be at the point D, okay, and at the point D is x away from C, so we can answer the x. So we're gonna x equal 9 over square root of 7 is the distance from C to D, and this is approximately 3.4 kilometer.